Hello, everybody. You might want to brace yourselves for this one because this is probably the hardest section of this unit, but I know that you'll be able to get it, and you always push through on this kind of stuff, so I'm not worried about that. But don't feel bad if you have to watch parts of this video a couple of times to figure out what's actually going on. Once you get the process down, that's the hardest thing, I would say, is to say, okay, first I do this step, then I do this step, and continue that way. There's two kinds of problems that we're going to do today, and the ones that are probably going to take the longest by far is finding the circle given 3 points. Now, we've talked about this just a little bit back when we were in class, and we said that anytime that you have 3 points, no matter where they are, you can make a circle in between them. So, for example, if I just make like 3 points like that, I can say, well, here's my rough outline of where the circle might be that touches all those 3 points. But I don't have to make a circle that looks sort of like an equilateral triangle. I can make these 3 points into a circle. And those 3 points are going to just be somewhere on the edge of a circle that goes through all 3 of them and continues out this way. So no matter what 3 points you pick, you'll always be able to find a circle that all 3 of those points lie on. And there's a way to do it using, obviously, geometry if we're given the coordinates of the points. So here is the process. And it's kind of long, but it's not complicated. We've done all of the things involved in this process already. So I'm going to draw out on this circle over here what we're actually finding. So we have a circle, and we've been given 3 points on the circle. So I'm just going to give, 3 random points there. Maybe those are the points we were given on the circle. And the first thing that we want to do, number 1, is find the midpoint and slope between each point. Maybe I'll call this A, B, and C. So if I find the midpoint of AB, maybe that's like right here, and I find the midpoint of BC, maybe that's like right here. And I could find the midpoint of AC as well, but I actually don't have to for this process. So I found the midpoint of AB. Maybe we'll put little congruency marks to show those are the same, and some is here as well. Then we need to find the equations of 2 of the perpendicular bisectors. So we're looking at this section, this segment AB, and we're going to say, I want to find the perpendicular bisector of AB. So I want to find the line that goes through AB, through the midpoint, in a perpendicular way. So here is perpendicular, it makes a right angle. And then, if I take BC, and I find the perpendicular bisector of BC going through right here, perpendicularly, through BC, through the midpoint, and I make that line, I kind of sketch it out, and that's also perpendicular, then what happens is that the place where these 2 lines meet each other, the place where the 2 perpendicular bisectors meet each other, is the point which is the center of the circle. All right, and if you think back to when we learned more about circles in chapter 10 in our first trimester, we learned that a chord is always going to be perpendicular. We can always draw this perpendicular line from the center to the chord. And that's the reason why this process works. We can always find the perpendicular line between the chord and another chord. Those perpendicular bisectors will intersect at the center. Once we find the center of the circle, we also need to find the radius in order to make it into a equation. So we can just take the distance between the center and any of the points. Maybe I'll use this point right here. And we can find that distance using the point and the point, and that'll give us the radius. And once we find the center and the radius, we can make the equation. Let's try one of these. So find the circle containing points A, 2, 1, B, -2, 3, and C, 3, -2. So first of all, we're going to start with finding the midpoint between each point. And I'm actually only going to use A, B, and BC. I don't actually need to use AC because, again, only 2 of these perpendicular bisectors eventually are going to be used. So to find the midpoint of AB, we do the midpoint formula. So we're going to take x1 plus x2, 2 plus -2, divide by 2. And then we're going to take y1 plus y2, 1 plus 3 divided by 2. And that's going to give us 0, 2. On the other side, BC, we'll find the midpoint of BC, and that's going to be negative 2 plus 3 divided by 2. And 3 plus 2 divided by 2. Or sorry, 3 plus negative 2, rather, divided by 2. And so the midpoint for BC is going to end up being 1/2, 1/2. I'm going to turn those into decimals, so 0.5, comma, 0.5. Then we have to find the slope in between these 2 points, because in order to create the perpendicular bisector, we need to know the slope of the original so that we can find the reciprocal slope for the perpendicular bisector. So let's find the slope of AB. We'll do slope, and we remember that that is y2 minus y1. So 3 minus 1 over x2 minus x1, negative 2 minus 2. And that gives us 2 over negative 4, which reduces to negative 1/2. The slope for BC will be negative 2 minus 3, y2 minus y1, over 3 minus negative 2. All right, and that is going to give us negative 5 over 5, which reduces to negative 1. Once we've found the midpoint and the slope, we're going to go to step 2. Find the equation of 2 of the perpendicular bisectors. So once we find the slope of AB, the perpendicular bisector is going to have the opposite reciprocal slope. So I'm going to put that here and say reciprocal of this line, the reciprocal slope is positive 2, right? Because we flip our fraction and we make it positive to find the reciprocal. So our slope of the perpendicular bisector is going to be 2. For the BC one, we'll put our reciprocal. And the reciprocal of negative 1, if we take negative 1 and we put it on the bottom of a fraction and flip it over and make it positive, the reciprocal is a positive 1. All right, we talked about reciprocals earlier this year. So those are my reciprocals. I'm going to then find the equation. We're going to go back to point slope form to find the equation, if you remember point slope form, because what I have in order to create the perpendicular bisector line is I have that point. I have the midpoint of AB, and I have the perpendicular slope, the reciprocal slope. So I'm going to use the point slope formula to find that. So that's, remember, I'll write the formula, y minus y1 equals m times x minus x1. So I'm going to plug everything into there that I've got. So I've got y minus my y coordinate, which is 2, equals my slope, the reciprocal slope, which is 2, parentheses x minus x1, which is 0. All right, and once I've got that, I want to turn it into slope-intercept form, into y equals mx plus b form. So I will do the distributing here, and I've got y minus 2 equals 2x, and I want y on its own, so I'll add 2 to both sides, and I get y equals 2x plus 2. So there's one of my equations. Got to get the equation for BC, so that's going to be y minus 0.5, my y coordinate, equals my reciprocal slope, 1, times x minus 0.5, my x coordinate. So then I'm going to do, again, the same thing here, distribute. So y minus 0.5 equals x minus 0.5, since that 1 doesn't do anything. Add 0.5 to both sides, and I get y equals x. So I have 2 equations now, the equation of my perpendicular bisector to AB and the equation of my perpendicular bisector to BC. So we'll go into step 3. What we are looking for is the place where these 2 perpendicular bisectors intersect. So what we can do is set up a system of equations and solve that system to find the solution to the system, which is where those 2 lines are going to cross each other. So I've got the equation y equals 2x plus 2, and I've got the equation y equals x. And those are easy equations to make into a system because they both have y equals. So since they both equal y, I can set them equal to each other and say 2x plus 2 equals x. and then I can just solve this. So since they both equal y, they're equal to one another. So then I've got to subtract 2x from both sides, and I get 2 equals negative x, divide by negative 1, and x equals negative 2. So there's another piece to this puzzle. I also need to find, obviously, the other coordinate. Since I'm solving a system here, I'm going to kind of put a line there. So to find the other coordinate, I plug it in. Well, I know y equals x, so y also equals negative 2. This is the coordinate point negative 2, negative 2. That's the coordinate point where the two perpendicular bisectors intersect. Therefore, that's the coordinate point of the center of the circle. So this is the center. Next, we need to find the radius of the circle. So I'm going to use the center, negative 2, negative 2, and I'm going to use any point on the circle, and I'm going to find the distance between the center and that point. So let me use the point 2, 1. And I'm going to find the distance between these 2 points because that's the radius of the circle. So I'm using the distance formula, the square root of x2 minus x1, so 2 minus negative 2 squared, plus y minus y1, 1 minus negative 2 squared. So then we just reduce there. So we've got the square root of 2 plus 2 is 4, so 4 squared, plus 1 minus negative 2 is going to be 3, so 3 squared. That's going to give us the square root of 16 plus 9, which is the square root of 25, which of course is 5. So 5 is the radius of the circle. I have the radius, I have the center, so I'm going to now be able to find the equation, finally. So my equation is, put it down here, equation, going to be the HK format with the H and the K being the points of the center. And we know our HK format is x minus h squared. So I'm going to say x plus 2, since I have a negative here and a negative in the formula, squared, plus, again, my y coordinate is negative, so that's going to be y plus 2 because I switched that sign, squared, equals my radius squared. So my radius is 5, therefore my radius squared is 25. And this is what I was looking for the whole time. All this work is going to lead me to that equation right there. All right, so it's a lot of work, but it's all stuff that we've done before. So let's do another example here. Find the circle containing the points 4, 4, negative 3, 1, and 5, 3. So here, we're going to do exactly the same process, just the same thing again. So we've got to find AB, and we've got to find BC. We're going to start by finding the midpoints of those two. So MP midpoint. The midpoint of AB is going to be 4 plus negative 3 over 2, comma, 4 plus 1 over 2. The midpoint of BC is going to be negative 3 plus 5 over 2, comma, 1 plus 3 over 2. All right, and so the midpoint of AB is going to be 0.5, comma, 2.5. I'm leaving this in decimal form because that's just easier for me. If you want to do it in fraction form, that's totally fine. And then we've got BC, which is going to be 1, comma, 2. Those are our midpoints. Then we got to find the slopes here. So the slope for AB is going to be 1 minus 4, y2 minus y1, over x2 minus x1, negative 3 minus 4. And that is going to give us negative 3 over negative 7. And of course, we can say that that's just positive. So that's positive 3/7. So the slope there is positive 3/7. Let me zoom this in a little bit. And we've got to find the slope of the other one. So slope of BC. And in order to do that, that's going to be 3 minus 1 over 5 minus negative 3. And that is going to equal 2/8 or 1/4. Got our slopes. The next step is we want to find that equation between, or the equation of the perpendicular bisectors, which means we need to find the perpendicular slope, the reciprocal slope. So here's the reciprocal, and that's going to be 3/7 flipped on its head and negative. So -7/3 is the reciprocal slope, and that's about -2.3 repeating. I'm going to, again, go to decimals because I like them better. And then the reciprocal over here is flip the 1/4, we get -4. So those are my slopes of the perpendicular bisectors. We've got the slopes, we've got the points. Let's make the equations of the perpendicular bisectors. So the equations here, some shorthand, EQN. So the equation of this one is going to be y minus y1, 2.5, equals m, -2.3 repeating, parentheses x minus x1, 0.5. And then I'm going to do my distributing here. And I've got y minus 2.5 equals -2.3 repeating x plus negative times negative 1.16 repeating. And then I've got to add 2.5 to both sides. And we've got y equals -2.3 repeating x plus 3.6 repeating. So there's one equation of a perpendicular bisector. The other one has less decimals involved in it. So this other one is going to be y minus 2 equals your slope -4, parentheses, x minus 1. And then distribute y minus 2 equals -4x plus 4. And then add 2 to both sides. Y equals -4x plus 6. So there's your other perpendicular bisector equation. We're going to take those two equations and we want to see where they intersect, because where they intersect is the center of the circle we're looking for. So we're going to take y equals -2.3 repeating x plus 3.6 repeating, and y equals -4x plus 6. And we're using those as our system. And since they're both equal to y, we set them equal to each other. So -2.3 repeating x plus 3.6 repeating equals -4x plus 6. And then we just solve this equation. So we'll add, I like to just solve by adding the smaller number of variables. So we'll add 4x to each side. You can solve this equation any way that you'd like. So I've got 1.6 repeating x plus 3.6 repeating equals 6. We'll subtract 3.6 repeating from each side. This is just solving. 1.6 repeating x equals 2.3 repeating. And then we'll divide both sides by 1.6 repeating. And we get x equals 1.4. All right, so 1.4 is the x value. Got to find the y value because, of course, this is a system of equations. So we're going to take y equals -4 times 1.4 plus 6. And that works out to y equals 0.4. So the coordinates of our center are, 1.4, comma, 0.4. All right, and that last step before we can give ourselves the equation is to find the radius of the circle. So we're going to take this point, and we can take any of the points we were given, and we're going to find the distance between them. So I'll use 4, 4. That was A. Going to find the distance between them to find the radius. So here is the distance formula. So we've got x2 minus x1 squared, so 4 minus 1.4 squared, plus y2 minus y1 squared, so 4 minus 0.4 squared. And of course that will give us 4 minus 1.4 squared is 6.76. I just did some math on a different sheet of paper. plus 4 minus 0.4 squared is 12.96. Put those together, we've got the square root of 19.72. Since there's already a decimal under your radical, you can go ahead and keep the decimal here, and that's going to be 4.44. So there's our radius. We've got the center, we've got the radius, we can make the equation. So we've got the equation, x minus 1.4, the x-coordinate, squared, plus y minus 0.4, the y-coordinate of the center, squared, equals the radius squared. So 4.44 squared, just look backwards in your work and you know what it is. It's going to be at 19.72. And that, my friends, is the equation of the circle we are looking for here. So kind of a lot to process, but in terms of any new math, we're not doing anything new. We're just kind of putting everything together. We also have another thing we're going to do. This is almost like doing half of the problem from before. We're going to find a line that's tangent to a circle. So what that means is we've got a circle, and we say, well, what about the line that's tangent to the circle at this point? The line that goes towards the circle, touches it at one point, and keeps going. How are we going to find an equation of that line? So here's what we do. Step 1, you find the center of the circle. You determine the slope of the radius. So we've got to find the slope of the radius. And remember this, when we learn this, from the radius to the point where the line is tangent to the circle, that makes a right angle. Okay, that's going to help us. Because if we find the slope of the radius, we're going to find the opposite reciprocal slope. And that slope, that new one, is going to be the slope of the perpendicular tangent line. So we'll find the slope of the tangent line, and at that point we will have a slope at a point, and we can make that equation. So here is the equation. We've got our circle. It is easy to find the center of the circle because it's in HK form. So our center is -3, 4. Remember that this is a +3, which means our center is negative. This is a -4, which means our center is positive. And we want to find the slope. And it's the slope between the center and the point we're given, because that's our tangent point. So the slope between -3, 4 and 2, 7. So we've got y2 minus y1, 7 minus 4 over 2 minus -3. It's going to be 3 over 5. So the slope of the radius is 3 over 5. We've got to find the reciprocal to that because we want the slope of the tangent line, which is perpendicular to the radius. So we've got the tangent slope will be the opposite reciprocal of 3/5 or -5/3. And now we've got a slope. Now we've got a point. 2, 7 is the point we're using because that's the point where this is tangent, right? Imagine that that is 0.27. So we're going to use y minus y1, so that's going to be 7, equals -5/3, parentheses, x minus 2, the x-coordinate. And we'll go ahead and finish this out. So y minus 7 equals -5/3 x. I'm going to be brave here and keep using fractions. So -2 times -5 is +10/3. And then we'll add 7 to both sides. So y equals -5/3 x plus 10/3 plus 21/3 is going to be 31/3. All right, if you have it as decimals, that's totally fine. But this is the equation of the tangent line. And that's all there is to that one. And finally, another example of this kind of thing, find the equation of a line tangent to the circle, and they give us this equation. Step 1 is to find the center of the circle. This one, we need to actually look to find the center. So we need to reorganize this. We need to solve using completing the square like we did in the last section. So we've got, I'm going to rearrange this so that the x's are next to each other and the y's are also next to one another. we've got x squared minus 2x plus y squared plus 12y equals 15, all right? And I'm looking for the center of this circle, so I'm using completing the square, b over 2 squared, negative 2 over 2 squared is going to be positive 1, and then we've got b over 2 squared, 12 over 2 squared is going to be 36. So we're going to complete our squares, complete our perfect square trinomials. So we've got x squared minus 2x plus 1, and that's one of our trinomials, plus y squared plus 12y plus 36, there's the other one, equals 15. We added 1 on this side, we'll add 1 on this side. We added 36 on the left, we'll add 36 on the right. And then we'll simplify this down. So we've got x minus 1 squared, again you can take that b value and cut it in half to figure out what the factored form will be, plus y plus 6 squared equals, and then 15 plus 1 plus 36 is 52. So the center of this circle is now evident in the equation. Our center is the coordinates positive 1, negative 6. We switch our signs again. So 1, negative 6. And we're going to find the slope. So we've got our center, going to find the slope of the radius. So we're going to find from this center point to the point negative 5, negative 2, what is the slope? So that's going to be y2 minus y1, negative 2 minus negative 6 over x2 minus x1. So that's going to be negative 5 minus 1. And that is going to give us 4 over negative 6, which will reduce to negative 2/3. So the slope of the radius of the circle is negative 2/3. We're going to find the tangent slope, the opposite reciprocal slope there. So the tangent slope is positive 3/2, or 1.5 if you're like me. And so we're going to put that into the equation. We've got our tangent slope. We need where we have the point of tangency. That means where does my graph cross the circle? Where am I looking here? Where do the circle and this line intersect each other? So we've got y minus y1. That's the coordinate from up here. Can't see that here. Y plus 2, because it's y minus negative 2, equals 1.5, parentheses x plus 5, because it's x minus negative 5. And then we're just going to simplify that out. So y plus 2 equals 1.5, x plus 5 times 1.5, 7.5. And then we'll subtract 2 from each side, and we get y equals 1.5x plus 5.5. And that is the equation of the line, which is tangent to the circle, which touches the circle in one spot, and the spot that it touches that circle is negative 5, negative 2. So this was kind of a mouthful. This is going to be your largest assignment, like I said, for not your largest assignment, but probably your most complicated one for this chapter. But I believe in you. I know you can do it, and you know that you can get at me with any questions. So that is all for now. Go ahead and work on the worksheet for this section.